Hi, I'm Jamie. I'm a sophomore at Brown studying CS.
Hi, I'm Devlin. I'm a sophomore here studying electrical engineering. And this is 6.5 pounds of PLA plastic scraps we've accumulated from 3D printing. This makes approximately a tenth of all the filament we use in our operations at our 3D printing company, Topo Prints.
Currently, Topo Print specializes in topography from mountains to craters, lakes, and canyons. You pick a place and we print it.
We've sold 128 3D prints to our customers, mostly hikers, skiers, and other outdoors enthusiasts across 12 different states and generated over $5,300 in revenue.
Specifically, we've made deals with Yokohama, several stores on the West Coast, and have also spoken with interested buyers in Yosemite National Park who we plan to work with this year.
And while it's great we're finally profitable, the $760 we spent on filament has really sunk into our profit margin. So what if we could design a system that cut down on our filament costs while also using up some of our old plastic waste?
Well, the 3D printing market is growing rapidly, valued at almost $13 billion. However, this growing industry produces approximately 10 million pounds of plastic waste each year. Plastic waste just like this.
And that pales in comparison to the overall 40 million tons of plastic waste generated by just the US alone in 2021.
We've all seen headlines of marine animals trapped in plastic waste and of ocean plastics contributing to greenhouse gas emissions as they decompose. So we have a rapidly expanding market opportunity and a huge global problem.
And one that's costing us a lot of money.
So we decided to put them together and design our own 3D printer.
We plan to tackle plastic waste production at its source: households, institutions, and businesses. We'll combine the multiple facets of the chain from plastic waste to 3D printed part into one. A user will drop plastic waste into a hopper at the top, which the machine grinds into small plastic shreds, dries in a storage container below the shredder, and holds for later use. A pellet extruding module melts the plastic shreds to produce the desired part.
Our goal is to employ this technology in manufacturing businesses, universities, and in households for our fellow 3D printing hobbyists. We've conducted a survey here on campus to test the efficacy of such a system in large institutions. Students' primary sources of disposable plastics were dining hall containers, cups, and utensils. Materials all composed of PP, PET, and PLA plastic.
Just like the stuff we've been piling up in our bin.
So what if we could use these materials to fuel the 3D printers at the BDW, for example? What if we could enable universities and companies to convert their plastic waste back into useful items?
We think we have what it takes to make this happen. On the engineering side, I've been designing and machining different projects since high school and have been working to design a detailed CAD model for our printer as well.
In terms of software, I'm passionate about systems programming, and I've worked with robotics since junior year of high school.
Last summer, we gathered supplies and began designing the printer. The big problem is distance, however, as I live in South Carolina and Jamie lives in Mass. We really hope to continue our work this summer at B-Lab as it would provide us the space, time, and entrepreneurial expertise in our endeavors. We are really passionate about this idea and can't wait to work throughout the remainder of the semester and especially this summer at B-Lab. Thanks for listening, and we really hope to join you this summer at B-Lab.